Good morning, students. Welcome back to your mathematics class. I will be continuing with the same topic, that is integration, and in that particular part we have already discussed about the meaning of this particular word integration. I have already provided you certain study materials, certain formula list for learning, and I hope you have already done the entire job, isn't it? Now, today with the standard integrals, I'm going to start your class. We have so many subparts of this particular indefinite integrals, which will be telling us how to do or perform an integration of a function with various techniques. Now, this is a preliminary topic, that is standard integrals, and these particular standard integrals can be solved by using the basic formulas I have already provided you. Okay, so after completing this particular portion, we will be going to substitution, then by parts, then partial, then so many others. So let's begin the class with the preliminary portion, that is standard integrals. So I have chosen certain problems for you which will be marking from 1 to 2 marks. So here you can see in the board that the first problem I have chosen for you is e to the power of 2 log x into minus 3, x to the power of minus 3 dx. Let us understand how to solve it. See, in this particular portion, I have something to tell you. I hope many of you have understood that we must first reduce it like the one we have already done in class 11. We have already learned the properties of a logarithmic function and exponential function. So this particular 2 can come over x, that is x squared, and we all know e to the power of log fx. What I said? E to the power of log fx is fx, and here fx is x squared. So now you can see very well this problem is now reduced to a very simple integration, isn't it? So here we are going to substitute x squared as I have reduced it to, and this is x to the power of minus 3. Now, what is the value of this one? So, this is 1 by x dx, whose value is already known to us. So, this is what I was telling. Here, after reducing the integrand, you will be getting such type of integrands here whose values are known to you directly. We don't have to put a label after it. Okay, so this is the first problem. So let us move down to the second problem. As all of you can see, the second problem is integration 5 to the power of 2 log x with a base 5. Now I need to tell you one thing here, students. We are actually very much well acquainted with the base e or 10. So one more property of log, let's recall that. One more property of log, what does it say? If you have something like this, how can you reduce it? This is log A by log B. But instead of this one, I will be using the same formula as I used before. Now how it is possible? Because the last formula used in the first problem, please all of you notice that I said e to the power of log fx, and the base was there e. So it was fx. Understood? So here it is 5 instead of E. So I am writing here 5 instead of E. And instead of E here, if it is again 5, okay, then it will be again fx. If it would have been something else, then it may not be the same formula. We would have continued with some different technique. But here, in this case, please focus in this, the particular part I want to explain you, that it will be giving you the same, that is fx. Must remember these two things should be same. Okay children, so here again a 2 is there like the before. See, so this 2 will surely be coming with this x. So it will be x to the power of 2. And the fx now becomes, fx is now x squared. So the entire integrand is now x to the power of 2 dx. And the reason behind it, the one you will be writing here, the formula. Okay, so now the integration of x square dx, as for the formula we have studied, that x to the power of n dx is x to the power of n plus 1 by n plus 1. So here 2 plus 1 by 2 plus 1. So I hope it is clear. The two problems I have chosen, they are of actually same type but with different bases here. Okay, so after the first two problems, let us move down to the third one. The third one, for the third problem, we have 4 to the power of x, 9 to the power of x dx. Can we write all together? Yes, we can write that. Now, definitely this particular integrand is making us recall the same formula from the list. And what was that? Yes, that is a to the power of x by, children, don't forget to write that c always, okay? Make it a habit. A to the power of x by log a. Now children, I am going to apply the same thing here. Here what is a? 4 by 9. So a direct answer. These problems are good for MCQ parts where you have 1 marks only. So you are going to, you're supposed to apply a direct answer. You don't have to work out, you don't have to show me, but the formula should be memorized very nicely so that you can do very quickly. Okay, so the answer I'm going to write here, 4 by 9 whole to the power of x by log 4 by 9 plus c. So I hope the first three problems which are carrying 1 marks is clear to you. So after this first 3, let us move to the second lot of problems. Now let's see this question number 4. What it is? Cos 2x minus cos 2 alpha by cos x minus cos alpha. Now, this type of problem will carry maximum 2 marks. Okay. Now, we have to first reduce this one to x. That is by the formula. Let us do that. So, cos 2x. How can we write it? 2 cos square x minus 1 cos 2 alpha can be written in the same way, and keeping in mind there is a minus sign in between. So see, this minus 1 and plus 1 is going to cancel here. Okay, so the denominator, I am not hampering the denominator here, let it be as it is. Let's see, this particular 2 comes out and we have a cos square x minus cos square alpha. So this is a square minus b square. So what is that? A plus b into a minus b. So keeping in mind the formula to be applied here, one factor from the numerator and the denominator cancels down. Okay students, so after cancelling, what we are getting? I am going to get only the factor present in the numerator, that is cos x plus cos alpha. So now the entire integrand is reduced to a simpler form. We can solve this integration by solving them separately. So cos x dx and cos alpha dx. So cos x dx, it is giving me the answer of sin x, integration of cos x dx, sin x plus c later on I will give. What about this? Tell me. Cos alpha dx. Yes. Is there someone who is saying sin alpha? No. I would have loved if there is a interaction with you. I could hear from you people. So this is to be kept in mind. This is a constant. Okay. So this is a constant which is coming out from the integration part. So this is only integration of dx. I hope it is very clear to everybody. So cos alpha and integration of dx, as we have discussed, this is x which is I am writing in the beginning, plus c, we should never forget to write down. So this is the answer for this particular integration, and I hope it is clear to everybody. So after this, I am going to erase it. We will be moving towards number 5. Please have a look on the number 5. What it is, what the numerator is having, cosec x. In the denominator, cosec x minus cot x. This particular thing reminds me of a trigonometric identity, that is cosec square x minus cot square x. How much? Yes, it is 1. Okay, so how to eliminate this denominator? Let us multiply the numerator and the denominator of the integrand with cosec x plus cot x. Now you have to understand what is the reason behind of this multiplication. Because I know something. What it is? The denominator can be removed here in this particular problem by this trigonometric identity. I will tell you one more problem where such trigonometric identity is going to help us. So for that, let us multiply the numerator and the denominator with the required factor. See children, and the denominator becomes 1 after this particular multiplication. I hope the target is fulfilled now. The denominator becomes 1. I am only left out with the numerator now. So this becomes 1. I am going to raise this denominator. I am not bothered about it anymore. Equals to. Separately getting the value of this particular integrand. Here it is. Cosec square x. Who can answer? I think some of you are answering in your mind only. So it is minus cot x. And what about this? Yes. That is minus cosec x plus c. So this is over. See, in this particular problem also, we are using only the standard integrals. Very simple tricks, very simple techniques are used in these standard integral problems, isn't it? So as I am telling you that I will again tell you one more problem which is coming into my mind, that this is the problem I was talking about. So see children, here we have a numerator that is 6 in the power. So I am going to turn this entire numerator in the formula that is of a plus b whole cube. How can I write that particular a cube plus b cube as? I can write it as like this. I hope it is understood to everybody. This is the formula I am going to use. Please keep an eye on this particular conversion of the numerator, and here it goes. I am going to write this numerator sine to the power of 6x as, and this will be as, okay, now this is a cube plus b cube, and I am going to write that in the numerator as a plus b whole cube. So a plus b whole cube, 3ab. This is a, this is b, and a plus b. A plus b is sine square x plus cos square x. This is the numerator, entire numerator, and the denominator. And this is dx. Am I clear? So this entire thing becomes how much? 1. This entire thing becomes how much? 1. So after making this one 1 and that one 1, so what am I getting? So let us see. After putting here 1, this is I am writing 1, you can see, and this is also I am going to write 1, so I am not writing this entire thing. So the numerator is now reduced to this. Now I am going to use separating the numerator. So please look very carefully children. Separating the numerator like this. Okay, so 1 by sine square x cos square x is one part, and 3, this will cancel, and the another part. So let us erase the entire thing, and I am going to rewrite. This is integration 1 by sine square x cos square x dx, and this 3 is now after cancelling, it is only 3 dx. Okay, whose integration is 3x plus c. I will write at the end. So in the denominator it is sine square x cos square x. So see how can we do it. Let us rewrite. So please try to understand that how many times am I using this formula. I was telling you in the previous problem only, that we are using so many times the trigonometric identities. So I am again writing this one. So let's again separate it. This is sine square x by this and cos square x by this. Again see, sine square x by this. So sine square x by this means what? 1 by cos square x. Cos square x by this means 1 by sin square x. And 3x plus c. So this is how much? This is sec square x. So this is the one whose formula is known to us. This is the one whose formula is known to us. Correct. So this is tan x. This is cot x. And this is minus 3x plus c. So this is the answer. Now look very carefully how many times I have blended it and how many times I have applied the trigonometric identity here. So there are plenty of problems, children, you will be getting in your book, and something in some study material also I will be providing you certain problems for practicing. Okay, so it is advisable to you, please go through this particular video and learn few basic concepts, and you keep on every day you practice minimum like if possible, and I think you can do it, minimum 30 to 40 integral problem when it is started. Let it be from example, let it be from exercise. It is the on-day thing which is going to uplift you and the speed will increase. Daily sit with this particular topic and definitely you will do excellent in the upcoming examination. Okay, so that's all for today in the class. Have a good day.